In this video, I'll be showing how I integrated RabbitMQ as a message broker into my mini microservice architecture. In this setup, I have two independent services, the auth service, that's the authentication, and then the email service. So basically, the auth service handles user authentication and authorization, whilst the email service is responsible for sending emails such as OTP, welcome messages, password change, notifications, and more. So let's dive in. A quick notice: I have both services running locally on my PC and I haven't deployed them yet. So before I start the service, let me give a quick overview. In both services, under the configuration folder, I have a RabbitMQ config file that basically handles all the core functionalities of the RabbitMQ message broker. So inside the same file, I've defined the keys for each service, the exchanges, the routing keys, and some core functions like initializing the Rabbit server and performing a graceful shutdown. So basically all the essential helper functions needed for the RabbitMQ to work smoothly. This is where I started both servers. If you look closely at the terminal, you will notice I have two terminals open. You can see the icons on the far right. Each one represents a different service. So since this is a console-based demonstration, I made use of an npm package called Winston to create my custom logger. This helps me track responses and every action that happens in the services console. So yeah, bear with me if you notice my focus shifting more toward the terminal instead of the code itself. So immediately after starting each service, the logger kicks in and then begins displaying logs of various activities. But our main focus here is how RabbitMQ allows seamless communication between services. I tested my endpoint using Postman, which was running in the back. Right away, the logger showed an incoming request in my auth service terminal, which I would attach to the video. So it performed all the necessary actions and then published a message to the email service under the event name user created to send a welcome email to the respective user. So this the email service consumed that message and then requested the OTP value from the auth service through an internal route. Now mind you, this route is protected by an internal API key to ensure secure communications between various services. So now you might wonder why I didn't include the OTP value directly in the published message from the auth service to the email service. Well, imagine if the RabbitMQ queue ever gets exposed. So yeah, I had to take that one into consideration. It would be a security risk. So instead, I stored the actual OTP in Redis cache, allowing the email service to call the auth API securely and then fetch the stored OTP. So finally, I would say the email service consumes the necessary queues and then sends both the OTP email and then the welcome message to the user. And that's exactly how I used RabbitMQ as a message broker in my microservice architecture.